A warm good afternoon to everyone. Am I audible enough? Yeah, good. Thank you. All right. Respected dignitaries, professors, academicians, and the vibrant AI community who have gathered here today. My name is Kapil. I am a mechanical engineer by profession. I specialized in robotics and mechatronics. But today I stand before you as the founder of Dossier Nexus. Before I get into what Dossier Nexus actually does, I want to say this. I don't want this to be a very technical talk. Instead, let's take this towards an approach-oriented talk, an approach towards implementation of AI in education. I want to start a question which has been bothering me for the last few years. So we have algorithms for admissions. We have algorithms for ranking papers. We have algorithms for recruitments, even for going viral. But do we have algorithms to help learner when they struggle? Do we know what to do with them when they struggle to make a decision about the next step in their life? Do we have algorithms for that? In those cases, we rely on humans. We rely on teachers and parents and the wider society to catch us mid-fall. And actually, those humans are also exhausted, doing the same thing again and again. Why? The answer to that question changed how I look at AI in education today. So I would like for us to get to that answer together, starting by tracing history a little bit. But before that, one second. Yeah. Just a small profile uh, about me. Now I'll move on to the history part. It's 1853. Let's visualize the Crimean War happening. British soldiers are dying left, right, and center. They're dying from disease, from infection in the hospitals, rather than they're dying on battlefields. Soldiers come in wounded but recoverable. They enter the hospital ward and they die immediately. Doctors are baffled. They blame bad air, some say bad luck, some even say it's the nature of war. They work harder, they try different medicines, nothing changes. Then one day, we all know this woman, Florence Nightingale. She, she arrives at Scutari Hospital in Constantinople. She's a woman in a man's world. She's a nurse in an age when nursing was even yet a profession. She walks into this chaos, overcrowded wards, wounded men lying in their own waste. But instead of pushing herself like everyone else, Florence asks a different question. What do the numbers actually tell us? She starts collecting data, actually, very obsessively indeed. She counts deaths by cause, she tracks hygiene practices, she documents which wards have higher mortality rate. She collects thousands and thousands of data points like this. Then she does something radical with these data points. She turns those numbers into visual stories. Those famous rose diagrams called as the coxcomb charts. When you look at those diagrams, the story becomes undeniable. But here's the crucial part. She doesn't stop at this visualization. She uses these insights to change how decisions were made. She convinces military leadership to rebuild hospitals with better sanitation, with better protocols, and better institutional practices. Those practices have been the foundational stones for systems we use today in institutions. Thousands of lives were saved during that time, not through heroic effort or sacrifices, but through better decisions informed from better data. That story happened around 170 years ago. And yet, when I look at academia today, at how colleges, universities, training academies make decisions about their students, I see something that would be familiar for Florence. Decisions are being made in silos, with partial information, with delays that cost real opportunities to students. We have infinitely more data right now. We have AI, we have the technology that Florence couldn't have even imagined back in that day. And yet, the way we make our decisions are still like it's 1853. I'll explain that in a little bit. So, let's take an example from here so that it's easier to follow through the problem. Let's take an educator. I'll just give her a random name. Let's call her Priya. Priya is intelligent. She cares deeply about her students. Now, visualize her. It's the start of a semester for her. She's designing a training program, let's say, for teaching coding for students. Let's keep it simple. Let's take 150 students in her class, maybe around 10 weeks of program. She's sitting at her desk, a laptop in front of her, multiple tabs open, a few spreadsheets open in front of her, and she's facing something that sounds simple, but it's actually very overwhelming for her. She's making decisions about other people's lives. Should Arun be in the morning batch or evening batch? Should Neha, she's from a different background, she doesn't have coding experience. Should we put her up with some extra mentoring time? Should we give her extra resources? If yes, who mentors her? If not, does she fall behind with the rest of the class? So by the end of the first week alone, Priya would have made thousands of micro decisions like this. By week 10, she's managing real-time decisions about every single learner. As we said, Priya is brilliant and she cares deeply. But Priya is also exhausted by this. Because she's trying to do something human cognition was never designed to do at scale. That is, make thousands of consistent decisions, high-quality decisions about other people. And here's the question that keeps me up at night. If we can't expect Priya to make good decisions for 150 students, how do we expect this to scale to 1,000 students, to 10,000 students? Simply put, we can't. So what do institutions do naturally? They dilute these decisions. They try and make as less and less decisions as possible. We make one-size-fits-all programs. We make a curriculum for everyone. Opportunities are sometimes even matched by roll numbers. We have accepted this. This is how it is done at large, right? This is our life right now. And what's the cost of this? Students start falling through the cracks. Opportunities never reach the right people at the right time and the right moment. In the end, human potential gets wasted. This is not, we are not talking about AI potential getting wasted, we're talking about actual human potential getting wasted here. So why humans fail here? Here's what I've learned studying this problem for some time. It's not a lack of intelligence, it's a cognitive architecture problem. Human brains are extraordinary at one thing, making one deeply thoughtful decision with context. You can spend an hour with a student, understand their background, learn their style, see their potential, and make a brilliant decision about what they need, about their future. That's where humans shine. That's where educators shine. But humans are terrible at making 10,000 similar decisions consistently. Here's why. First, working memory is limited. Research says we can hold about 7 variables in our mind at once. A decision about a learner might require 50 variables at a time. By the time we have processed all of it, we are exhausted. By the 1,000th decision, we are already running on fumes. Second, decision fatigue is real. Every decision costs cognitive energy. After enough decisions, our quality crashes. We start taking shortcuts. We make biased decisions without even realizing it. Third, We can't learn about across decisions. So back to the example, Priya makes a great decision in week 2, makes a similar decision in week 8, but she doesn't systematically learn from those patterns. Why? Because each decision happens in isolation. Each will be for a different student with a different context, different circumstances. So the result is institutions scale by diluting these decisions and not multiplying them. That's the reality today. So instead of personalizing for every learner, we created a one-size-fits-all solution. Instead of making intelligent decisions, we make fewer worse decisions. And we have accepted this. We think this is how just scale works. Now, we have actually produced a breakthrough solution for this. We have been using this for a long time, and that's called automation. For years, when people talk about AI in education, they talk about automation. AI will grade papers, AI will help with tutoring students, AI will help with admissions, AI will help with placements and recruitments. AI will make decisions for you. And I get it, automation is actually appealing. It's fast, it scales, but it's also fundamentally wrong about decisions, about human beings. Because here's what automation means. The system decides, humans review the exceptions. You train an AI model to predict which students will drop out. The model flags students, you, the human, then scramble to figure out what to do. Or worse, the system automatically enrolls them in support programs without even asking you. And here's the hard question in all of this. Do we really want to build systems that decide for humans, or do we want to build systems that help humans decide better? Because there's a different approach than automation. What if instead of automation, we built for augmentation? So augmentation means humans decide, the system provides the intelligence, signals, and the patterns to help make better decisions for humans. So back to the same example, imagine Priya designing her program this way. She encodes her intent once. I want to support learners who struggle with basic concepts. I want to flag them their disengagements if they're struggling. I want to pair these learners together. So these kinds of small decisions which she makes, she can teach. She can tell this as intents to the AI. And over time, as Priya makes decisions, system learns her patterns. You have decided 3 times to pair learners with non-tech backgrounds with experienced mentors. This new learner matches that profile. Should I send the extra resources they need? In this model, Priya is still making the decisions. The system is making her smarter, faster, and able to scale her good judgment across all the 150 learners in her class. So opportunities are not matched based on roll numbers. Opportunities are given based on human decisions which suit those learners now. So augmentation preserves what's human and irreplaceable. That is the judgment, care, and the intent behind them, while scaling the parts that machines do better. That is spotting patterns, monitoring thousands of variables in real time, and learning from past decisions. So it's not replacing educators here. It is giving educators some superpowers now. So we talked about automation and augmentation right now. We'll talk about why actually this problem matters the most right now. So I want to tell a story about a mathematician named Richard Hamming. Probably most of the mathematical or computer science students might know him. He worked at Bell Labs in 1950s and 1960s. So Hamming was brilliant. What made him legendary was not his work. It was his lunch conversations. His colleagues noticed something strange. An unusual number of scientists who had lunched with Hamming went on to win Nobel Prizes. They would have a conversation over lunch. Months or years later, these conversations would echo in major discoveries. So people started asking, what does Hammings do in this lunch sessions? So the answer was simple. He asked two questions. I want all of you to pay attention to these two questions because I wanted to ask you to ask this to yourself again and again. So the first question is, what is the most important problem in your field? And the second question, why aren't you working on it? So most people, when asked these questions, would get uncomfortable because they realized their day-to-day work wasn't connected to the big problem they actually cared about. They were busy, but not on what mattered. And that discomfort, it often became the starting point to some of their best work. So a few years ago, I asked myself these kinds of questions. So what is that most important fixable problem that I care about? And I sat with this question for a long time. Not how do we create more content? There's already more content than any human can consume. Not how do we hire better faculty? Institutions are full of brilliant people. Most of them are right in front of us today, giving back to the community. So you see, all my peers and juniors used to ask, uh, why did you choose this path? Why did you take up engineering? Why did you choose this after your 12th or 10th? Why did you choose to study in this college? How did you find your actual interest or your passion? So those brought me to this approach of how do we make decisions about who learns what, when, and with whom. Because that is the lever. Get those decisions right with better insight, better timing, and better fairness, and everything else cascades. So my question back to you is this. Do you find this as an important problem? If so, why aren't most of us working on this now? So our approach is AIDNA. AIDNA works in 3 integrated layers, and they work together to solve this problem. So layer 1 is intent understanding. We'll go back to the example again. When Priya designs her program, she is encoding her intent, what she cares about, what she's trying to achieve, and most systems right now lose that intent. It lives in Priya's head alone or in scattered nodes. AIDNA learns that intent naturally through the course of her life cycle. Then it applies it consistently across all the 150 learners in her class. That intent becomes the infrastructure. I want you to remember this word infrastructure here. Next is layer 2, real-time signals. So in traditional systems, the cycle is slow. So we design the program, we wait for the program to get completed, we get the results, we plot graphs, statistics, then we make changes to the next batch. So by then it's too late. You've already lost the struggling learners with these incremental changes year on year. So with AIDNA, the system streams these signals in real time. This peer group is not being very active. Should we check in? These learners are stuck on the same concept. Shall we schedule a question and answer session with them? So each signal here is a decision point, not an algorithm deciding, but the system saying, here's a moment where your attention could matter. What shall we do here? So, and because these signals come in real time, Priya can act actually at the exact same time and actually change the outcome of those learners in her class. Now layer 3, predictive support. Over time, AIDNA learns Priya's patterns. When learners from non-tech backgrounds struggle with their first coding task, you always pair them with a mentor and extend the deadline. This new learner matches that profile. Should I send these resources? Priya still decides, but now backed by her patterns from her own past decisions. So over time, you and the system develop an intuition together. The system becomes like a trusted colleague who knows how you think. Together, these layers let Priya make thousands and thousands of good decisions instead of trying to do it all manually. Here's what Aidna looks like in practice. So Priya, I want you to think of this example in a different way now. Priya sets up a program with Aidna, same 150 learners start. Week one, signal starts coming in. Priya catches these disengaged learners very early. She gets recommendations on peer pairing based on skills and learning styles. She sees modules which confuse the learners the most. She connects with people. The program doesn't feel so chaotic anymore. It feels very responsive. It has more feedback to the educator and the student as well here. By the end of week 10, learners don't just get a certificate, they get a learning portfolio, proof of skills they have demonstrated, evidence of what they can do, connections to opportunities that match their potential. So next year, when Priya runs the program again, she's not starting from scratch. She knows what worked, what didn't, where learners struggled. She iterates, the programs also gets better with her iterations. Suddenly, education isn't about learning alone. It's about matching human potential with human opportunity. So, the vision behind this platform, for centuries, education has been bottlenecked by human attention. A great teacher can deeply influence maybe 100 students in their lifetime. Those students go on to influence others. Some of them have come back to influence you guys. But the patterns of how that great teacher decides, how they support these learners, how they see potential in them, those patterns usually die with them. If Priya is brilliant at spotting when a learner is about to give up, and she knows exactly what to say to bring them back, that brilliance exists only in her interactions. It doesn't scale. It doesn't get documented. It doesn't improve with each generation. But what if it could? What if we could extract those decision patterns from great educators, distribute them as operating systems that others could use and improve, and create a marketplace where expertise actually scales? What if a program run by a brilliant educator in one city could use that program's decision patterns to improve outcomes for learners in another city? What if institutions could learn from each other's experiments, what worked, what didn't, and build on that collective knowledge? That's not replacing humans. That's making human expertise contagious. That's making it possible for brilliance to scale. That's what Edna is building forward toward. Okay. Before I close the session, I want to ask a question before I get off. If Florence Nightingale could change hospitals with data in 1853, what could we change in academia in 2025 if we actually built the infrastructure for data-driven decisions? Right now, all of this might sound aspirational, so let's make it concrete. I wanted to show you a quick demo of Aidna in action. We took the liberty of giving the context of today's conference to Aidna, which then went on to organize the whole conference on its own. So this is the AI Spectrum event. This is the overview of the event. So it has taken in the details from the websites. It has built a complete about of the event today. It has started building a dashboard of registrations, how much sales and everything is going on. It has also taken the agenda from the website, and it also started building those agenda on its own. You can actually ask it to I'm just asking it to add a keynote session. Okay, I think my network is not good today. But yeah, please do come check us out in the stall in the auditorium, so we can show a deep demo on how everything works. It also automatically sends announcements to students, teachers, the faculties, and the guests who are arriving uh, about the sessions, what they need to be, where they need to be on its own. It also took the liberty to create a website on its own. We have a complete web builder within the platform itself. So this was completely generated with AI. It just took a reference of the current conference, and it just added all the context in the form of a website, ready to go, ready to be shared automatically. It also created registration forms for all these participants will be coming in, will be submitting their call for papers as well. So author's name, paper, and everything. So all those details will be collected back in this registrations uh, database, where once these people start submitting them, people can view them, check in, and all those kinds of stuff, which you usually do. There is submissions, there is certifications, there is analytics and everything. But what this platform really excels is where it starts taking these decision patterns when you start building these conferences one by one, what kinds of decisions you do, or it can be conferences, it can be a course, it can be a training, it can be a small workshop, it can be a hackathon. It takes all of these decisions, and it starts understanding your intent, and then it starts working with you to make everything possible for you without that exhaustion, and without being a one size fits all for everyone. It will actually personalize those experience for each learner, each person who is part of this system. Okay, so lastly, all of this wouldn't have been possible if not for our lovely team here today. So their hard work and sleepless nights and strong work ethic has made this moment possible for us. So my co-founder Kumaran is here. He's a veteran in the field for more than 25 years. He has headed one of the topmost companies in Germany. Finally, before I finish, in the spirit of AI in education, we would like to take this opportunity to announce a program designed for students with the launch of the Future Leaders program. This is part of we have a subdivision called Dossier Labs. So Dossier Labs is a research division of Dossier Nexus focused on applied AI. So we have currently partnered with Indian Council of Agricultural Research to bring homegrown AI models and applications to support farmers in their decision making and improve agricultural productivity in India. Currently, we are piloting over thousands of acres in Tamil Nadu, soon to expand pan-India over lakhs of hectares. So we do face the same implementation problems associated with farmers as mentioned by Professor Yadati. So we invite, so in this juncture, we would like to extend an invitation to the PSG tech team to join hands with us in bringing AI for India from Coimbatore. So thank you all for your time, and thank you, Dr. Karpagam. I think she's not here, for this opportunity. Looking forward to talking with everyone soon. Please do visit in our stalls. We'll be happy to see how we can build AI for your use cases. Thank you.